Hello everyone. Today I am here to discuss about far from equilibrium process. So what far from equilibrium process is? It refers to systems that are not in thermodynamic equilibrium and are subjected to external forces or influences that drive them away from a state of balance. In biological system, many processes occurs far from equilibrium. And understanding these dynamics is crucial for studying various phenomena from biochemical reactions to cellular metabolism. I will give you the key concepts and association with far from equilibrium process. First of all, we will discuss about the thermodynamic principles. First is non-equilibrium thermodynamics. Systems that are far from equilibrium do not follow the simple laws of equilibrium thermodynamics. Instead, they require a more complex framework that account for far dependent change and flux of matter and energy. The driving force. In driving force, the gradient force, the far from equilibrium process are often driven by gradients like concentration, temperature, chemical potential that creates fluxes. For example, diffusion of molecules from high to low concentration is classic example. External work, like systems can be driven out of equilibrium by external work such as mechanical force, chemical reactions that provides energy input. If we give the example in biological system, like there is metabolism. Cellular metabolism operates far from equilibrium. Enzymatic reactions often have high activation energy barriers and are driven by consumption of substrates, and these release of products maintain a dynamic state far from equilibrium. Another example I can give you, cellular processes like protein foldings, DNA replications, cellular signals often involve non-equilibrium dynamics where molecular interaction are influenced by external condition and energy inputs. Now, if I say a mathematical modeling, we can talk about the kinetic models. Far from equilibrium process can be modeling using kinetic equations that describe the rate of change of concentration on populations over time. Now, applications. Understanding far from equilibrium process has implication in various fields, like in biochemistry, biophysics, systematic biosynthetic bios, like in biochemistry, insight into enzymes, kinetics and metabolic pathways. In biophysics, understanding molecular motors, cell motility and transport mechanics. So in conclusion, I can say that far from equilibrium processes are fundamental to understanding the dynamic nature of biological system. These processes highlights the importance of energy flow, gradients and interaction in maintaining life and driving complex behaviors. By studying these systems, researchers can gain insight into how life operates at molecular level and how it adapts to change environment. In synthetic biology, designing engineered systems that operate far from equilibrium in specific functions. In systematic biology, modeling complex interaction with biological networks. In biophysics, understanding molecular motors, cell motility and transport mechanism. Okay, thank you all of you. We'll see you in next video with the next topic, inshallah.